Okay, another partial fractions. You do need to recognize that the denominator is not completely factored yet. So I'm going to rewrite 3x plus 1 over x times x plus 1 times x minus 1. I have three unique linear factors, so this is going to become the sum of three fractions. Each one is a constant over the linear factor. We multiply both sides of the equation by the common denominator. Okay, on the left, the entire denominator cancels and I just have 3x plus 1. And on the right, when I distribute to the a fraction, the x's cancel, so I have a times x plus 1 times x minus 1. And then distribute to the b fraction, and the x plus 1's cancels, so I have bx times x minus 1. And then distribute to the c fraction, so I have cx times x plus 1. Choose some convenient values for x to plug in, because this equation has to be true for all x's. So I'm going to plug in a 0 first, so this becomes 1 equals negative a, and the other two terms go away because I'm putting in 0 for x. So that means that a is negative 1. Let's see, the next x value I'll plug in will be negative 1. So that's negative 3 plus 1 is negative 2. My a term drops out. My b term becomes b times negative 1 times negative 2. And my c term drops out. So this means that b is negative 2 over 2, which is negative 1. And then I'm going to plug in x equals 1. So the left-hand side is 4. 3 times 1 is 3, plus 1 is 4. And my a term drops out. My b term drops out. And I'm left with c times 1 times 2. So c equals 2. So I'm going to rewrite my integral as a, negative 1, over x, plus b, negative 1 over x plus 1, plus c, 2 over x minus 1, dx, and integrate term by term. So I get negative ln x minus ln x plus 1 plus 2 ln x minus 1 plus c. So this is another partial fractions problem. The decomposition is going to look a little bit different on this one because we have a repeated linear factor. So I'm going to rewrite 1 plus x squared over x times 1 plus x squared. So 1 plus x is a linear factor that happens twice. It's squared. So I have one unique linear factor, so that's going to be one of my fractions, a over x. And then I'm going to have a b over 1 plus x and a c over 1 plus x squared. So the rules for linear factors say you have to put a constant over the linear factor, and then the linear factor squared, and then the linear factor cubed, until you have hit that exponent. So now we just multiply both sides of the equation by the common denominator. On the left, everything cancels, and I get 1 plus x squared. On the right, my first fraction, the x's will cancel, and I get a times 1 plus x. I should have written out the common denominator for you. Okay, the common denominator is x times 1 plus x squared. Okay, so on the left, everything cancels. On the right, I have a times 1 plus x squared. And then when I distribute to b, one of the 1 plus x's cancel, and I have bx times 1 plus x. And then when I distribute to the c fraction, I get cx. So I choose some values of x to plug in. I'm going to start with 0, so I have 1 equals a, and the other two terms drop out, so a is 1. I'm going to choose x equals -1. So I have 1 plus 1 is 2. I know a is 1, but this term is going to drop out anyway. -1 plus 1 is 0. Then I have b times -1 times 0, so that term actually drops out. And then I have c times -1, so negative c. So that means that c is -2. Okay, now I'm going to pick any value of x I want. There is no third useful value of x, so I can just pick any value, maybe 1. So 1 plus 1 squared is 2. I know a is 1, so this is 1 times 1 plus 1 is 2 squared, plus b times 1 times 2, plus c, which is -2 times 1. So I get 2 equals 4 plus 2b minus 2. So 2 equals 2 plus 2b. B has to be 0. So my integral becomes the integral of a over x, and a is a 1, so 1 over x, plus b over 1 plus x, and b is 0, so that I'm not even going to write that term down, plus c over 1 plus x squared, and c is -2, so -2 over 1 plus x squared dx. Okay, so I can integrate term by term, so this becomes the integral of 1 over x dx minus 2 times the integral of 1 over 1 plus x squared dx. Now this integral, I'm going to use a u sub to solve it. The first integral is just ln x. So I'm going to make a little note over here. Okay, so I'm going to let u be the inside of my composition, so u would be 1 plus x, which means that du equals dx. So this is the integral of 1 over u squared du, and that's the integral of u to the -2 du. Add 1 to the exponent, and I get u to the -1 over -1 or times -1 plus c, and u is 1 plus x. So this is -1 over 1 plus x plus c. So when I come back over here to finish my integral, the integral of 1 over x is ln x, and then I have -2 times this expression. The -1, I'm going to multiply by that negative and make it positive, and I get 1 over 1 plus x plus c.